All right, there we go. 12. Sorry, I'm West Coast US time still. Hello, everyone. Thank you so much for joining this session. I really appreciate you being here. I know I'm between you and lunch, so you must be really interested in this session. So thank you so much for coming. My name is Adrian Iliesiu. I'm a principal engineer with Cisco. I'm actually part of the DevNet team, which is, we have the DevNet zone right there. We always like to collaborate with the Cisco U folks and have these sessions, kind of interpollination. They have sessions there, we have sessions here. So thank you so much for coming. I'm a developer advocate at Cisco, right, where I cover enterprise networking, specifically Catalyst Center, Catalyst SD-WAN, Meraki, and IMSXE. So if you folks start automating or you start working with our Ansible collections for these platforms and products, or a Terraform provider, or an SDK, or you need sample code, reach out, please. I'm more than happy to help you. But for today's talk, we're actually going to talk about CI/CD pipelines. So how many of you are using CI/CD pipelines for anything today? Okay, so that's a decent number. Good, great. So the agenda for today is we're going to have a quick overview at what CI/CD pipelines are, just making sure we're all on the same page. We'll talk a bit about GitLab, which is the version control system platform that I'm using for the demo. Then we'll go into the demo. I have a recorded demo, but that's going to be taking the most part of this presentation. We only have half an hour. And then I have some resources for you at the end, some links. If you want to build the demo that I'm showing you, right? I have actually recorded this and streamed it on Twitch. So I have like 12 hours of content that you can go through, video content to set up everything from scratch, from installing CentOS to getting GitLab running, to getting Ansible in there, to getting pyATS, so the whole thing, right? So if you want to set up what I'm going to show you in a lab environment, you can do that by yourself. And also, like I said, ask questions, more than happy to help. All right, so you folks, some of you are using CI/CD pipelines. For the rest of the other people, CI/CD pipelines have been there. Software developers have been using them for many, many years now, right? It's like 10, 15 years. Folks have been using these pipelines to actually help them deploy their applications, right? So as a developer, you work on features, you work on software, right? In a team, most probably. And you need to have a central location, right, where you gather this code, right? So the CI in CI/CD stands for continuous integration, and this is pretty much the first stage of a pipeline in which you just gather the code from all the developers, right, in one location. It's usually a Git-based solution these days. And it's basically the practice of integrated code, bringing it together and starting to run some initial tests, right? You want to catch bugs as soon as possible. You want to make sure that the feature that these developers are building is actually performing as expected, right? So you get the code, you do some initial testing on it, some integration tests at this stage, right? So that's kind of like the first stage of the pipeline. That's what you usually do. As you move to the second stage, right, the CD in CI/CD stands usually for continuous delivery. And here is where software people basically take that code and they build the application. So if it's a Java application, right, they spit out a jar file, or they start, if it's a Python application, that they would probably start a container, right, install Python in it, right? So it's at this stage, the application gets built. You had the feature, the code, central location, then you build the application, and you do some additional tests, and you make sure that it runs, right? And then if you want to take your pipeline to the next level, once you have your application built, you can deploy it, right, to a production environment. Ideally, in a continuous delivery, you've tested it in a sandbox environment, test environment, making sure that it works. And then in the continuous deployment stage, which is the final stage of these pipelines, is that you deploy that application to production, right? So this is the way that large companies are building software and they're developing features and deploying them. You have Facebook, right, your Amazons doing this on a daily basis. So using these pipelines, they can spit out and enable and deploy features at an unprecedented rate compared to what it was before. So all this is automated, right? By the way, so all these steps is just, it used to be that there was a QA team, right, or a build team that would take the code. There were actually physically people back in the old days that they were taking the code, right, building the application. There were QA people testing it. Well, all of that has been automated, right, with the CI/CD pipeline. So folks have been, replaced a bit with these pipelines. So that's the software development world, right? But what about us, network folks, and people that are, dealing with infrastructure? Can we start using these pipelines to kind of help us do configuration management, right? Similar to developers, they have source code, which is just text at the end of the day. We have configuration files for our devices or infrastructure, right? So it's very similar. So there's an option of actually us tagging along and starting using the CI/CD pipelines for actually configuring and managing our infrastructure at the same time. So with the pipelines, the configuration changes are done through automation. So you kind of have to have an Ansible or a Terraform or some type of solution that's going to do the configuration for you. So that's an automated way. You get the advantage of having a historical insight, right? So as you do your configuration, you push them to a central Git repo and you save them there, you get a history. So whenever somebody comes and performs a new change, they create a new VLAN or they remove an interface or whatever it is, you can always revert back to the previous version, right? Because version control, that's its main purpose. It's keeping track of all the changes that you've done over not only you, but the whole team, right, that they have done over time. So you can revert back at any point to a previous version. And of course, you can have a test environment, right? You not usually do these changes directly in production. You could use something like CML, Cisco CML, right? Cisco Modeling Labs. They have a demo right here, Ralph. If you're not familiar with CML, it's a fantastic product. It's what used to be Cisco Viral, right? But then the pandemic hit and they decided to change the name. And if you folks know GNS3, Eve, NG, that type of stuff, right? So it's like CML is the official product from Cisco that's going to give you the option of emulating in the lab environment your infrastructure. All of it, depending on how large it is, or just a subset of it. But the idea is that you get the chance of testing changes in that virtual environment, in the test environment, before you push them to production, right? So similar to what I was telling you about the sandbox that developers use, we can also have now like a sandbox environment for our infrastructure. And then if there's an issue with a change, right, it happens that the test environment, your CML environment didn't catch any issues, but then something happens in production, you can revert back and say, okay, revert back to the previous version of my configuration. And to make it truly CI/CD pipeline, you can integrate your pipeline with, like a ServiceNow solution for ticketing, or you could have the change done in CML. Everything works well. A ticket is being opened in ServiceNow. Somebody goes, approves the change in ServiceNow. That triggers the pipeline back and goes and pushes to production, right? So you can have Splunk integrations, ServiceNow, whatever other solution or workflow that you have in place. All right, so that's a quick overview of CI/CD pipelines, right? How developers have been using them and how you can kind of start looking at how we can use those pipelines also for configuration management. I'll show you a full pipeline working for an OSPF configuration for us. All right, so GitLab, how many of you are familiar with GitLab or have? All right, good. It's, it could be GitLab, GitHub. I'm using GitLab. I'm a big fan of GitLab because it has built-in CI/CD pipeline component, right? So if you were to start from scratch and build one of these pipelines, there's several components that come into the picture, right? You would have version control, clearly. Then you would have a build server. It's called, it could be like Jenkins, could be GitLab itself, could be Drone.io. There's several different products out there that do the build, which means that it's kind of like the management of your pipeline. So that's an application that checks at each stage, right? You define your stages, runs the pipeline, make sure that it completes successfully. So there's several components, but in our case, GitLab, besides version control, which was its initial purpose, it is this day a complete DevOps platform. So you can do project management in there. You could do track of issues, track of bugs, right? Track of all your changes. And like I was saying, the built-in CI/CD pipeline comes with GitLab included. So how it looks, the pipeline you have here on the left-hand side, once you install GitLab, and by the way, they have a community edition that is free. So you can install it in the lab. They also have an enterprise solution. You can run it on-prem or as a SaaS offering, right? But for the purposes of our talk today, they have the CI/CD component within GitLab, right? So you have here, you see several pipelines that are running. There's 4 running at the same time. There's a couple that's been canceled. And these are the stages, right? So, and we'll see in a bit how you define these stages and how it actually looks. But pipelines in GitLab are composed of jobs, right? So it's what you want the pipeline to do, and stages, which is like part of your pipeline. When do you want to run that stage? Is like the first part of the pipeline, second, third, fourth, or when you want to have it run. And a typical pipeline in the software development world contains 4 stages, which, like I was saying, is the build stage. You get the code, you build the application. Testing, where you run integration testing, unit test. Staging, where you deploy to a staging environment. And then production, where you deploy to production. Runners, that's a concept in GitLab, is it's just a process that runs, and whenever you do a git push, for example, right, you have performed a change in infrastructure, whatever it is, on one of your switches, routers. You do a change in a text file, you save that change, and you do a git push into GitLab, right, into that central location. So GitLab automatically triggers. You have the option of automatically triggering the pipeline, or you can just go and approve. By default, the pipeline gets triggered automatically. So I did a change, create a new VLAN, change an IP address, pushed it, right? The pipeline gets triggered automatically. And then it goes and it uses this runner process to clone the repo, right? And then execute the instructions in the YAML file that specify what the pipeline should look like. So these runners are important because you can run your pipeline. You can have create a virtual machine as part of the pipeline. You can create a Docker container, or you can Docker start a container, right? You could run a batch script. You could run an SSH connection. You could whatever you want. It's super customizable, and can do anything that you do manually today. The definition of a pipeline is very important. This file has to be in this format, and that's where you define your pipeline, right? At each stage, you see here, I have a couple of, well, there's 3 stages, but .gitlab-ci.yml, that is a special file that GitLab will know that that's where you have your pipeline defined, right? So when you do that git push, pipeline gets triggered, it's gonna look at this file, and it's going to go and execute step by step each stage as you defined it. So this one is pretty simple, just 3 stages. You specify what Docker image to use in this case, just using Alpine. And then it has several jobs that is going to run, right? So these two are part of a build stage. This is test, and these are deploy. These are just simple echoes, right? Bash commands in this case. All right, so let's go and have a look at the demo, because this is where everything comes together. And by the way, feel free to ask any questions if you folks have any at any point. And so for my test environment, I have GitLab as a source control, as my CI/CD pipeline. I'm using Ansible for performing the change as part of my pipeline, right? So I'm configuring OSPF on a couple of Nexus switches. I have my development workstation, which is just a Mac that would be the user, right? You, your team, whoever is performing the change. The hosting server is the CentOS. That's where I run GitLab. I'm using for my network simulation CML, right? So it's all in the virtual environment. And then I'm using pyATS as my testing framework. Are you folks familiar with pyATS? No, some of you are. If there's one thing that you take out of this presentation, check out pyATS. It's a fantastic framework, especially as you start working with pipelines, because it gives you the option of taking snapshots, operational snapshots of your infrastructure, right? Because if you perform a change with Ansible, yes, is going to go and configure SPF or whatever you want it to do, but it's not going to tell you, was that route actually propagated throughout my network, right? It's not going to tell you that, hey, my neighbor, did it learn the route? What's the operational status of that change? You're not going to know that. But pyATS comes in the picture, and it takes an operational snapshot. It's going to know all the routes that are on all your devices before you perform the change. It's going to know all the packets in, errors out on the interface. It's going to take a complete full snapshot of all your infrastructure, right? So it's very important, because I'm going to use this to take a snapshot before I make the change, right? Then I'm going to make the change, configure one more interface for SPF with Ansible, and then I'm going to take another snapshot as part of my pipeline with pyATS to make sure that the change got propagated, that new route has been learned throughout the network, right? So this is my test environment. So this is CML. I have a fairly simple setup here with just 2 distribution switches and a couple of CSR 1000 Vs in this case. And they have OSPF running throughout this network, right? I'm advertising all the interfaces. I have a couple of loopbacks. And these are just Nexus 9000 Vs. This is CSR 1000 V, which has been replaced with Catalyst 8000, right? So if you folks build this in CML, make sure you use that. So OSPF running in here, right? Routes have been advertised, learned. It's all working well. And there we go. Just showing that it's, and you have access, of course, to the console of these devices. Showing here, it's distribution switch 1 and 2. And then I have my GitLab running on CentOS, right? And here I have a folder. Let me just pause this. So in GitLab, I have a folder, right, that I called it CI/CD. And in this folder, you see I have my GitLab-ci.yaml. That file that I was telling you is important. That's what my definition of the pipeline is. Then I have group vars, host vars for Ansible, and my Ansible CFG. I have pyATS folder where I have my pyATS installation. I have actions, which is going to be my Ansible playbooks. They're stored in there. All right, so this is a folder that I have everything pre-installed and ready to go. So now if we have a look at that YAML file, that's how it looks. Right, so I'm going to use this image from Docker hub from the Docker Hub registry, which is a custom image that I've built. It's a Docker image that I've built. I've put it on Docker Hub, and I have in that image Ansible. I have pyATS, right? And that's pretty much it, right, in this case. So that's the image that I'm going to use. I have 3 stages as part of my pipeline. I have that pyATS pre-snapshot, like I was saying, right? So I'm taking an operational snapshot of all my lab environment. Then I have deploy OSPF. I'm going to use Ansible to deploy OSPF. And then I'm going to use, as part of the 3rd stage, pyATS again to take a snapshot post-change. And then at each stage, I tell GitLab what to do. Right? So there's pyATS pre-snapshot, script, change directory into the pyATS folder, and run pyATS job with this testbed file, with this trigger data file, right? I'm literally telling it what to do as part of the pipeline, right? So it changes directory, runs the pyATS job, and then what to do with the artifacts. And this is the output of what pyATS does, right? It's going to save it into this location as JSON files. It's going to always run it. And then deploying OSPF stage, I have an Ansible playbook. I'm telling it run the hosts from that file, and then actions configure SPF. That's where my playbook is, right? That's going to configure OSPF, and we'll get in a bit, and I'll show you how that looks. And then 3rd and final stage, right, is same thing. pyATS run the same job, but with a different trigger data file, and we'll get in a bit at how that looks. I'll show you. Right, so pretty straightforward. As the image, there's the stage. What is it going to do at each stage? And this could be, right, in this case, it's a script. You could have it do a virtual machine, right? Spin up as part of that. You could have it do an SSH connection as part of it, whatever you want it to do. And then last stage, post snapshot. And I'm running that job with the same testbed file. And this is basically just the YAML file with IP addresses, credentials, so that pyATS can connect to those devices and run the commands. Okay, so that's GitLab-ci.yaml. Very important because that's your definition of your pipeline. And then locally on that Mac machine, I have that repo that's on GitLab. I have it locally cloned, right? So I have, you see, there's the host vars, group vars, config actions, pyATS, and then the GitLab-ci.yaml. So in the host vars, that's where I start having my configuration for SPF, right? So I have OSPF process ID, router ID, and then I have several interfaces, 4 interfaces configured for OSPF on that device, which is 10.10.10.177, which is that NX-OS switch, right? So that's the config, the OSPF config, and let's add one more interface, a loopback 100 in here, 101 actually. So there's my 2 switches, 177 and 178. And we'll just create one more loopback just to show you how you could use these pipelines, right? You don't connect to the device. You just edit the file, attack a YAML file, you save it, you push it, and then triggers the pipeline, connects the devices. You don't touch any CLI at any point. Double checking that the interface, so there's no loopback 101, right, on neither of the switches. Same thing on switch 1. OSPF, neighborship is established, routes are being learned, right? It's all working well. I'm just gonna create and configure one more loopback interface as part of the demo here. All right, so I've done the changes on both switches, and I was telling you about that post trigger data file, pre and post trigger data file for pyATS. And this is basically where you tell pyATS what to do. All right, so I'm telling it show IP OSPF neighbors detail on device 1 and device 2, and make sure that it contains these neighbors, right? So pyATS is going to connect to the device, it's going to run this command for me, and it's going to check that I have neighbors on device 1, 25 and 33, that they're there, right? So neighborship is established, OSPF is working. Same thing on device 2, and this is part of the verify OSPF neighborships. You can do anything, right, with pyATS on those devices. I'm just checking OSPF because that's our setup here. So I'm checking that the new routes, right, the 101.2 and the 101.1 have been learned by each device, by the neighbor. So switch 2 knows about loopback 101 on switch 1, and switch 1 knows about loopback 101 on switch 2. I have 3 files that I've changed, right? So I do a git commit. I've added loopback 101. I do a git push. That's gonna push to GitLab my configuration, the new changes. I'm gonna log in as developer. All right, and that is it. That automatically triggered the pipeline. If I go back into GitLab, I go into pipelines, the pipeline is already running, right? So I have added loopback 101. It's running. It has 3 stages: pre-snapshot with pyATS, deploy, and then post-snapshot. I go in the first one. It's gonna get the Docker image from Docker Hub, right, where I have all my tools pre-installed, right? It's gonna git clone the repo into that Docker image, and it's gonna run the exact steps that I've told it in the GitLab-CI.yaml. So here it took a snapshot. It verified that OSPF neighbors are up, right? That routes have been propagated. So its job has been successfully completed. Goes on to the next stage, which is deploying OSPF running Ansible, right? So it's gonna run that playbook that I've told it under the actions folder, right? Actions, configure SPF, run that playbook that is gonna go parse that group vars, host vars, and configure the new interface using Ansible on both devices. And then last stage is gonna go and make sure that the new loopback has been learned between those switches. Right, so you have 177, 178, change 4, 101.1, and 101.2. They have been changed. Loopback 101 on both devices. Job has been successfully completed. And then you go stage 3. It's going to take a snapshot and verify that routes indeed have been propagated. So now I go and double check on the CLI. I see I have a new loopback. I can do show IP OSPF neighbor, show IP OSPF route, show IP route OSPF, right? And I see that route on both devices now, and it's being configured by my pipeline, right? I've not touched the device. I've not connected over CLI. I've just edited 3 files, right, in the GitHub repo, or GitLab repo, saved them, commit, push, and that triggered the pipeline, went, performed the change, right? If anything happens, pipeline fails, then you need to go and investigate what happened. That's why a test environment like CML comes in handy. So I have the routes learned on switch 1, the loopback from switch 2, and same thing on switch 2, I have the loopback from switch 1. And the pipeline completed successfully. So at this point, right, you could, let's say this is in a branch called testing, right? You do a git merge into your production branch, and that goes and pushes to production, right? Or you can have someone manually go and merge the branches to production where it's going to go and deploy into your actual network. Resources, quickly, like I said, the YouTube playlist, you can watch 12 hours of me going and troubleshooting this. I've run into all types of issues, NTP not working, right? Getting NTP working on CentOS, it's all types of stuff that happen. But there's the playlist, GitHub, there's blogs, I've wrote about this. Any questions, let me know. Like I said, if you're trying to set this up, it's not rocket science, and it's definitely going to help you a lot, especially as you start working in larger teams, as you start working with infrastructure as code, right? All these concepts, keeping track of all the changes, using automation is going to really help you a lot. Thank you so much. Any questions, we can talk after. Please don't forget about the session evaluation. Let us know how we did, how I can change this to make it better. You can follow me on X or LinkedIn. Please feel free to connect, and thank you so much. Thank you.